right, so here are the checkpoint A corrections. If you're just if you need help with any of these, obviously you can fast forward if you don't need the first one, or you can fast forward to the one you need. So I'm going to go through all these. First off, it says the pair of values below is from a direct variation. So right off the bat, I know that whatever my k is, it's y divided by x. So I'm going to use the pair that I know, and that means the k is 7/6. So my equation then would be y equals 7/6 times x. You plug in for k. And then on this one here, they say plug in 12 and see what the new y would equal. So if I plugged a 12 in here, now ignore the x, I plugged it in for x, so x is gone. Now it's 12/1, do some reducing, it's 2/1, so that'd be 14. Okay, so for that one, that'd be 14. Number 2 is the relationship between the values direct, inverse, or neither. So first off, if it is direct, that means all the y's divided by all the x's are the same. So 60 divided by 4, that'd be 15. 30 divided by 8, that's not 15, so it's not direct. Now I'm going to check inverse, means multiply them together. So all the products will be the same. So 4 times 60 is 240. 8 times 30 is 240. 12 times 20 is 240. And 16 times 15 is 240. So that means this is inverse variation. And all of those where I just multiplied all those together, that's my k. My k is x times y. All the x's times y's are 240. So that's my k. So when I go to write my equation, it's y equals that k divided by x. So this one is letter B here, 240 divided by x. Number 3, find the equation variation in which y varies inversely. So if it is inversely, they're saying y equals k over x. Now I just need to figure out what is k. Well, remember k is x times y. If I multiply the x over, k would equal x times y. So in this case, if x is 10, y is 5, at this moment, multiply those together, k is 50. Put that up top. Okay, so that's this guy right here. So y equals 50 divided by k. Okay, let's go to number 4. 4 here. I'm subtracting, so I need to, first off, I need to factor this bottom here. So two numbers, multiply, give me 18, add to give me 9. That would be 6 and 3. If you're having trouble, just think this is probably one of them. So that's kind of a hint. So the least common denominator here would be a plus 6, a plus 3. This has the a plus 3, it needs an a plus 6. So I'll multiply by a plus 6 on top and bottom. So this would be a times a is a squared. A times 6 is 6a minus, and this does not need to be multiplied by anything because it already has the entire denominator. So that would just be minus 11 over a plus 6 times a plus 3. Okay, and then pick that one out of the lineup. What is that? D? Yeah, D. Here, first off, keep, change, flip. But before I write down what I want to keep, I'm going to actually factor it. So y squared minus 25 is y plus 5 times y minus 5. Y cubed on bottom, don't need to factor monomials. Change it to multiplication and then flip it over. So y plus 8 on top. And this guy, before I write it down, I'm going to factor. Well, the numbers, there's not a number besides 1 that they're both divisible by, but variable-wise, they are both divisible by y to the 4th. So if I took a y to the 4th out of both of those, that'd be y minus 5. So here I keep, change, flip, and I factor at the same time. So if I do some factoring here, y minus 5's cancel out. I got y plus 5 times y plus 8. So not this one, y plus 5, y plus 8. Not this one, y plus. And so it's one of these two. Now, if I have y to the 3rd times y to the 7th on bottom, that's y to the 7th. Don't multiply them together, add them. So that's this guy. Throw this one out. So yeah, this guy. I put an X there. I don't know if that's confusing. I'll try and mark it as that is the right answer. Number 6, we have some complex fractions. So first off, on the top, I need to simplify it so it's a single fraction. Okay, so this guy, it's currently over 1, but if I multiplied by s over s, that'd be 9s plus 3 over s, because they're both over s, so I just put over 1s. This here, 12, would be my least common denominator, so I'm going to multiply by 3 on top and bottom, so it'd be 3s plus 1 over 12, because they're both over 12 now. Okay, when you're dividing, it's keep, change, and then flip, so this would be 12 over 3s plus 1, so it came up here. The only thing that would factor out of all of these is this guy right here. I take a 3 out of this, so this would be 3s plus 1. Cross that out for a second. And now 3s plus 1 is on top and bottom, so that can cancel out. So we got 3 times 12, which is 36, over s. So 36 over s is this guy, letter D. And number 7, whole bunch of stuff. So it's multiplication. So I do not need to have the same denominators on this. So don't worry about LCD. This is simply factor, cancel, and then multiply. So I'm going to factor everything as much as I can. I might just rewrite it. So this first one here would be x, let's see. So positive product, positive sum means they're both positive. And that'd be 8 and 3. This one here, again, positive product and positive sum, so they're both positive, so it'd be 9 and 3 times, and this guy on top, there's no linear term here, so don't try to do 2 binomials. Just look at, is there something they're both divisible by, and they both are being multiplied by x, by 1x, so take an x out, and that'd be x plus 9, and then this guy, I have a negative product, so right off the bat, that means plus minus. So one's positive, one's negative. And I want to multiply, so I have the sum is 4, positive 4. So I need 2 numbers. The positive one is 4 bigger than the negative one. And that'd be 8 and 4 to give me negative 32 and positive 4. So I've got everything completely factored. Now start canceling. So you always want to factor first, then cancel. So I got x plus 9s, x plus 3s, x plus 8s. And all that I'm left with now is what, x over x minus 4. So that's letter B. Number 8 says add and simplify. So this one I do need common denominators before I add. Okay. So in order to do that, I need to factor the denominators to see what factors they have in common, and what I would need to multiply either one of them or both of them by so that they match. Okay. So this first one, if I factor this guy, let's see, has a negative product, that means it's plus, minus. I'm assuming one of them's 4. Okay, so I'm just going to give it a good guess. And then negative 4 times what equals negative 24? That's 6. And just double check, does that add to give me 2? And it does. So these would be the same if I multiply this one by m plus 6. I got to do it on top and on bottom. So now they are the same. I just got to look at the tops. So I got m squared plus 6m plus 9m plus 54. Okay. Some students here, they'll multiply by this, and before they add, they cancel. You do not want to cancel until after you've added. Okay. Because you multiply by this to make them the same denominator. If you then cancel, you just undid your first step, and there was no point in ever doing that. So be careful with that. Now, bottom I got m plus 6, m minus 4. This here simplifies, so m squared plus 15m plus 54. And you don't want to just stop right there, okay? Because if you stop right there, it's not factored all the way. Or it's not simplified all the way, because one of these might be in there. Because m squared plus 15m plus 54, let's factor that out. So I'm going to factor that into 2 binomials. And it would be really nice if one of them, either the 6 or the 4, was in there. So just think, is 54 divisible by, well, first off, is it divisible by 6? And it would be divisible by 6. is it divisible by -4? Well, you can't have a negative in this. -4, so m minus 4 can't be one of the factors because it's a positive positive. So it could be 6. Let's try m plus 6 and see if it works. So 6 times 9, and then what about 6 plus 9? Yep, and that's a 1, so it does factor. So again, I was just using the bottoms as clues. If you just factor like normal, two numbers that multiply to give you 54, add to give you 15, you'll also get 6 and 9. So the m plus 6's will actually cancel out now. And you got m plus 9 over m minus 4, which would be letter D, m plus 9 over m minus 4. Number 9, yeah, I'm solving this one. So I'm looking at these two. I want to solve these guys. And I would like to get rid of the denominators, so I need to multiply by the LCD. I noticed that they don't share any factors in common. If the denominators share no factors in common, and you have just two fractions, this whole side of the fraction, this whole side of the fraction, you can do cross products and set them equal. Or you can multiply everything by x plus 7 times x minus 1. Either way you do it, you're going to be taking x minus 6 times x minus 1, and you're setting that equal to x plus 3 times x plus 7. The work's going to look the same no matter which way you do it. So let's simplify these sides. So this would be x squared minus 1 minus 6 is minus 7x, and then plus 6. Over here I got x squared, 7x plus 3x would be 10x, plus 21. And then, let's see, so the x squareds cancel. So I'm going to subtract x squared from both sides. I'm just thinking about how much room I have here. So I'm going to add 7x, so plus 7x plus 7x. Since I brought the 7x to the right side, I'm going to bring the 21 to the left side. So this equals 17x, and on this side, I got 6 minus 21, which is negative 15. I need to divide by 17. So negative 15 over 17 is my answer for x. When I plug it in, neither one of those goes to 0, so it's good. I can keep it. I can still use that. Number 10, I can't do cross products because this side's not a fraction, so I don't want to do cross products. Plus, they do share out of all these, like these two share a factor and these two share a factor because that's actually x plus 2 times x minus 2 when I factor x squared minus 4. So when they share stuff, I want to look at every factor that I see. So like the LCD on this one would be x plus 2, and I see an x minus 2. And then the highest power of any of them have is a 1. So like this is x minus 2 to the first. This is x plus 2 to the first. They're all to the first power. So this is my LCD. If I were to multiply this first fraction by both of these, the x minus 2's would cancel out, and I would just have x times x plus 2. So I have enough room here. X times x plus 2, and the denominator canceled out. For the second one, if I multiplied by both of these, they both would cancel out, and I have just 8. And the last one, if I multiply, the x plus 2's would cancel out. So I'd have the minus 5 on top times x minus 2. And that is a step right there. When I distribute this, that's where most people probably made a mistake. Okay, so let's go x squared plus 2x on this side, 8 minus 5x, and then right here, this is negative 5 times negative 2 is a plus 10. So that should be plus 10. I'm going to go over here and rewrite it a little bit higher. So I got x squared plus 2x. On the right side, I got 8 plus 10 is 18 minus 5x. And since I have x's and x squareds, that means I want to do a quadratic and factor it. So I'm going to bring everything to the left side because I like to have a positive x squared. So x squared, when I bring the 5x over, it'd be a plus. So 2 plus 5x is 7x. When I bring the 18 over, it's minus 18. So that equals 0. And then I have to factor. So if that's a negative product, that means one of each. And let's see, to have a sum of 7, that'd be 9 and negative 2. So that means x equals negative 9 and positive 2. But double check, plug them back in. If I plug in 9 we're good. If I plug in negative 9. If I plug in a 2, that first one right there, 2 minus 2 is 0. I can't divide by 0, so this is my only answer, negative 9. Number 11, these guys, this, when you have a minus 6 with the x, that means right 6. And when you have a minus 3 on the end, that means down 3. So there's your first answers here. So 6 units, let's see, right, and then down. And then the actual graph then, so if I went right 6 and down 3, that's not right 6. That looks pretty like it. That's left. That's right 3 down 6. So it's this guy right here is the graph. Number 12. Oh, by the way, the shapes on that one too. Yeah, this was a reciprocal function, so that's the one where you have a vertical, a horizontal, and it's upper right, lower left. Oops, lower left. On this one here, it's got a squared, which means on number 12, it's going to be a volcano graph. So they need going up, which we gave you that one for free, basically, on the test. You didn't have to memorize the difference between the two. But this guy, if it's plus 7, that means you're going to go left 7. If it's minus 4, you're going to go down 4. And then, so if I go left 7, down 4, let's see, this is left 7. That looks like it's it right there. This one's right, this one's right, this one's right. So this is the only one that's left 7, so that has to be the answer. So that's your A. And the next one, this is one where we gave you the graph, and we're just asking for what is the domain of this. So you look at the graph there, each notch is worth 1, and if I go over 1, there's the vertical asymptote. So there's a vertical asymptote, x equals 1. There's a horizontal one at y equals 2, which is actually x equals 1, y equals 2 right here. The domain then is going to be everything but that one. So we want to say x not equal to 1, but they want it in interval notation. So that means it's everything, so from the left, so from negative infinity to 1, and then from 1 to infinity. So from negative infinity to 1, not including 1, and then union with 1 to infinity. So that would fit in there. So basically that's the interval notation way of saying everything but 1. Number 14, determine the domain of this guy. So this guy here we've got, it looks like every dash is worth 1. So if I go over 2, there's x equals 2. That's the vertical asymptote, x equals 2. And then y equals 1 is my horizontal asymptote. So if there's a vertical asymptote at x equals 2, it means 2 is not included. If I'm doing interval notation, it's from negative infinity up to 2, and then from 2 on to infinity. Okay. Number 15. 15 was probably the most overthought question because people were trying to mess around with the top and trying to factor the top when they're talking about undefined. So for all numbers that make this rational expression undefined, it means what numbers make it over 0. All I care about is the bottom. That's all I have to worry about is the bottom guy. So for number 15, you never use the top for anything. It's this size. So z squared plus 8z plus 15. I want to know what makes it equal 0. So let's factor it. Positive product, positive sum means they're both positive. So that'd be what? Plus 5 and plus 3. So that means z would be negative 5 and negative 3. So that's what, so the rational expression is not defined for these values, negative 5, negative 3. Because that's what makes it equal 0. And then number 6, again, probably even more overthought or overlooked. Find all the numbers and make it not defined. You're not solving anything, you're not simplifying anything. It's what would I plug in to make the bottom equal 0? The top is allowed to be 0. So for instance, some people had a 3 in there. They said 3 was one of them. Well, if I do 3 minus 3 over 6 minus 3, that's 0 over 3, which if you put in the calculator is 0. That's not undefined. That's defined. It's 0. It's nothing. So it's not that. But what would I plug in to make that equal 0? Well, if I plugged in a 6, so if I did 6 minus 3 over 6 minus 6, That'd be 3 over 0. If you type in a calculator, it says error because you can't do it. So 6 is a number I plugged in, positive 6. If I plugged in a negative 6, so negative 6 minus 3 over 6 minus negative 6, this would be negative 9 over 12, which is defined. That's negative 3/4. That's not 0. It's not undefined. So this is the only one. B is the only one that does it. Hopefully that helps you out. If you still have questions, let me know.